The Physical Properties of the Periodic Table by Grace, Caroline, Jake, Taryn, and Jack.
The first group we will talk about today are nonmetals. Nonmetals are classified based on 4 categories. The first category is that they are poor conductors of heat and electricity. Second, nonmetals cannot be shaped. Third, they're not as shiny as metals. And fourth, they're not malleable and gain electrons easily. Some examples of nonmetals include hydrogen, helium, oxygen, and nitrogen. There are plenty of other nonmetals in addition to these 4 that can be found on the upper right-hand corner of the periodic table. An example of a liquid nonmetal is bromine, which has a dark red and orange complexion. The easiest way to see nonmetals are to look at the upper right-hand corner on the periodic table. The next group we will talk about is the alkali metals. The alkali metal group is smaller and found in the first column of the periodic table, with the exception of hydrogen. This includes lithium, sodium, potassium, rubidium, cesium, and francium. Properties that all members of the alkali metals possess are: the first, lower densities compared to other metals. 2, having high reactivity with other elements. For example, sodium and water. Third, one loosely bound valence or outer electron. Fourth is a softness. And the fifth property is they melt at low points. The next group we'll introduce is alkali earth.
So, alkaline earth metals are very hard and denser than salts such as potassium and sodium. They also have higher melting points, the highest being beryllium at 1278 degrees Celsius. When heated, 4 of the elements give off characteristic colors. Magnesium is a brilliant white when heated. Calcium turns brick red. Strontium gives off a crimson color. And barium is an apple green. So the next group is transitional metals. They are generally hard and tough due to the strong metallic atom-to-atom bonding. They are good conductors of heat and electricity and are easily hammered and bent into shape. They have high melting and boiling points and are very dense.
Metals have both high melting points and densities. Metals also have a low ionization energy and electronegativity because it is likely to lose electrons in the outer shell of the atom. Another good fact that the electrons move easily is that it allows metals to be heat and electrical conductors. Also, because of their free-moving electrons, metal has the ability to be hammered into shapes and be deformed without breaking, unlike the nonmetals, which get crushed. Metals also oxidize and corrode relatively easily. A specific reaction of metals includes when iron reacts with dilute hydrochloric acid to form hydrogen. Halogen is a column of nonmetals and has a range of physical properties at room temperature. They range from solid to liquid to gas. Chlorine and fluorine are mainly gases, iodine is mainly solid, and bromine is found in its liquid state. They have 7 valence electrons, which is 1 short of being stable. Therefore, they are very reactive. They react most with alkali and alkaline earth metals and form stable ionic crystals. Fluorine is the most reactive halogen. Fluorine is found as a pale yellow gas and chlorine is a light green gas. Both gases are poisonous in nature. Iodine is found as a black shiny solid, and when heated, it forms a violet vapor. Lastly, bromine is a brown toxic liquid. Halogens also have very low melting and boiling points. Last, we have noble gases that includes helium, neon, argon, krypton, xenon, radon, and unobtainium. Noble gases are not reactive, and this is because they have valence shell of electrons is completely full. Because they are so stable, they have no desire to react and therefore are monatomic. As their name sounds, they are all gases at room temperature. They are odorless, colorless, fluorescent, and all conduct electricity. They also boil at low temperatures because they are gases at room temperature. They also have a high density, and this is because they are high atomic mass. The noble gases make up 1% of air and are separated by the fractional distillation of liquefied air.
Despite their name, rare earth elements are quite commonly found in the Earth's crust. They are called rare because although overall they are common, they are not found in large quantities, and therefore mining them is not cost-effective. The first of the 17 rare earth metals was found in 1787 in Ytterby, Sweden, and was named ytterbium. Since then, another 16 rare earth elements have been discovered, although few serve any major purpose. Ytterbium is used in LED TVs to help create pixels, while neodymium is used to create some of the strongest magnets on Earth. In general, many of the rare earth elements look metallic and are either silver, gray, or white. There are only 6 semimetals or metalloids that are universally considered to belong to the same group. Those are boron, silicon, germanium, arsenic, antimony, and tellurium. Carbon, aluminum, and selenium are also sometimes considered semimetals. Metalloids are in general metallic-looking, but too brittle to have any structural uses. They are sometimes found in glasses and semiconductors. Silly putty is made primarily of silicon. Boric acid, made from boron, is used often in insecticides as well.
Thank you for watching our video.